이것은 방향 로봇의 경우입니다.
You just watched the video of our logistic robot based on the standard platform and our implication. And you saw some differences, but it uses the same platform. And the concept was shown in the video. You don't have to know more about the robot. You don't really have to do a lot of maintenance of the robot operation. That is the key spirit of our company, and we call it CS. C means clean, and E is easy, and S is safe. So clean, easy, and safe energy is our corporate motto. Then why do we need the robots in logistics? As you can see, we are suffering from COVID-19 while our shopping is getting more and more developed, and it's almost like explosive mega hits in the logistics in Korea. But accordingly, we have some obstacles in logistics. As you can see in this chart, the top one shows the average work hour. The average work hour decreased, and then this bar graph is the labor cost. While the work hour decreases, the labor cost is getting higher, so it gives the company more difficulties. And JP Morgan analyzed the performance, and almost 50% is the simple delivery of the cargo. But when it comes to simple work, it means the big burden on human body because they walk around and carry things. And due to these work hours and the work conditions, it is not an option. It's essential for companies to consider the innovation, and that's why Amazon started to consider and do the research of the work environment improvement. If you look at the first graph, this is the outlook for global logistics robot market size. depends on who conducted the survey. It's different. However, at least 22 trillion won is expected in the market, and 53% is coming from logistics. And logistics centers started to introduce some robots, and this has become more essential for their operation. Then what are the advantages by introducing logistic robot? First, cost reduction thanks to automation. And the logistic robots usually deal with the delivery, and which help people remain safe. Here you see the employment. Remember, the high intense and more physical work will be done by robot, and the socially vulnerable people will have more chance to get jobs. Work efficiency is also one of the benefits. This robot implementation will enhance the work efficiency dramatically. And let me introduce our low robot. Our low robot has two ways to be operated. First one is LiDAR. It's a slam way. So once they run this robot, the picker designated somebody, and then by self-driving, it can communicate with the picker. And the speed can go up to 1.2 meters per second. And you may think it's slow, however, if you think about general speed of the people, walk is 5 kilometers, and that's like 1.4 meters per second. So in the case of the emergency, people have to be faster than 1.4 meters per second, and that is why robot is faster than 1.4 meters per second. And in general logistics centers, the loading capacity is usually up to 80 kilograms, but the robot can do 100 kilograms. The dimension is 600 by 1290 by 1000. This is an ideal size for the human workers, because when people unload some material, the height of the waist is very important. So, in fact, in logistics centers, people repeatedly sit down and stand up. You may think, but that's not the case. So even if they load and unload, they do not repeat sitting and stand up. So the 800 millimeter is the ideal height for workers. So let's say you can have a certain reach, and the ideal distance is 600 millimeter. So this low robot adopts the ideal dimensions of the width, length, and height. Then, as I mentioned, in hardware, then what about the usage of this robot? A lot of owners introduce the robots, and they usually concern three things. First, they want it to be cheap. Second, once they have new products new equipment into their factories, they wanted to make it useful to the fullest. And once you have a cutting-edge technology-based equipment, they wonder if they can do good maintenance without any error of equipment.
So we decided to develop this hardware and software for that purpose. This is RMS, and let me explain it. RSA stands for Robotic Management System, and this system is used as a warehouse management system. When the order comes from a warehouse regarding the things to be released, there should be some sequence of the released, but it is kind of mixed within the ordering system. So you reorganize the order to make it more effective and efficient. For example, as you see at the front, this is the entrance, and 3 orders comes from these 3 channels, and this route is the shortest route to receive all the orders. But if you produce random orders, the robot randomly goes one place to the another, so the routes become so redundant. So this RMS system organized the routes of the delivery to make it more efficient for robots. And next, of course, these robots must be controlled and managed real time. That's why you need the monitoring, additional monitoring system for robots, and monitoring data are accumulated in a server. For example, you can see the seasonal patterns of robot movements. This part movement in this part becomes larger during this time of the season. That kind of seasonal data can be produced. And like I said, this data can be fed back to the machine to improve the efficiency. Automatically, orders are created and distributed among robots. Then the next, the management of the robots. Smart care system on the bottom can be understood if you think about a car. When you drive a car for a certain distance, you need to refill the oil. RMS and smart care system are the same. For each robots, they track the distance they traveled. For example, this robot travels for a certain distance for this period of time, and on average, the monthly distance traveled is this much. And if robot runs this more, some part of the robot system must be replaced like this. Of course, there should be seasonal patterns of replacement as well. For example, these parts must be replaced for every certain distance. So this kind of analysis can minimize the downtime of robots. Also, remote AS, we call it AS, but actually warranty service. So if you have a computer, you don't bring the computer to the warranty service or repair service center. You remotely connect the repairman, and the repairman remotely connect to your laptop and fix the problem. Likewise, industrial system, 80% of the industrial trouble happens because of the software malfunction, not hardware malfunction. Given that, if you see some robot in the US malfunctions, you can fix the problem remotely from Korea. So we plan to create a repair shop in 3 major locations across the globe so that we can cover the entire time zones of the globe, so that we can provide a 24/7 repair and maintenance service as a smart care service. If it becomes successful, people would receive advices on the maintenance real-time 24/7. This approach, and another system is damage inspection system, which is a rare system that is hardly being seen in other areas. For example, in Amazon, they have hundreds of TIBA robots, and malfunctions and abnormalities of these robots cannot be detected manually by human operators. As you can see on here, if you see this dark room curtain, before the charging, you can create this additional place where the robot has to go through before charging. From 3 different sides, the robot is scanned, and that scanned image is compared to the image of the past days or a day before. If a robot is damaged because it clashed into some obstacles, it can be fixed readily. Or if the robot handles a liquid product, the fall of the liquid can contaminate the robots. In the case, this repair shop can be used as a repair place, or you can put some UV lights so that the robot can be sterilized if required. We use the dark room system to minimize the reflection of the light. The reflection light can damage certain part of the system, and by using this kind of dark room system, you can maintain the surrounding condition constantly. So if you put all this system into one warehouse, what would it look like? From WMS, the order given to each robot, and like I said, RMS redistribute the order system to make the task list more efficient. By doing so, operators and robots within a certain warehouse are remotely commanded or ordered. For example, at a certain point of time, robot unit A will visit you, and when a robot arrives near you, you do the work with the robot in 2 ways. 2 ways by here means that the operator, if the operator is a veteran, he or she can directly command the robot to follow him or her to pick. Within a warehouse, you might encounter error, wrong delivery of products. But this robot has an information of where to put certain items and where to pick certain items. In that case, you can put some labels on a product and let the robot to scan the label when it arrives. And by doing so, that scanning confirms whether the robot should move it or not, and if there is some misdelivered products, the alarm can be issued to minimize the possibility of false delivery. So far, I talked about the role logistic robot and its usage. Thank you so much for your kind listening.
Let's give him another big round of applause. And next, we would like to have a panel discussion with the presenters. And some of presenters left, but we still have Mr. Park Chun-sik from Hankuk Tire and the director Yoon Jong-chul of Hills Engineering. So we can have a free discussion with these 2 prominent speakers. I would like to ask Mr. Park Chun-sik to be a moderator for the discussion. And the remaining audience can bring up or present their questions to the speakers. And as an appreciation, we would like to give out the book called The Economic Growth 2021. Shall we start? Are you ready? We have a lot of audience on YouTube as well, so now I would like to ask Park Chun-sik to take the microphone. Nice to see you again. My name is Yoon Jong-chul from Hills Engineering. Let's have a big round of applause to start with. Thank you. Let me introduce myself again. My name is Park Chun-sik from Hanguk Tire.
And I think this is a reverse order. My name is Yoon Jong-chul from Hills Engineering. I should introduce myself again.
Thank you very much for listening, all the 5 presenters. Probably you still have some remaining questions or your feedback or insight from the presentation, or if you have any questions in the process of doing your work in robot or logistics. And in case you don't have a lot of questions, usually good moderators appoint people to ask questions. The gentleman over here, maybe I would like to ask first. Very handsome-looking gentleman can start the first question. Well, I am not really familiar with the robot, but I've been curious about the status of the robots. Cleaning robots are also widely used, and I believe it's a prominent industry. Do you know anything about it? So the status and the market outlook of cleaning robots, like a commercial cleaning robot. You talked about robots in logistics and factories, yes, but okay. For cleaning robots, I am not an expert in that area, but in terms of a general information of a robot, at least it will continue to grow because people are getting more fed up with some dirty, dangerous, difficult jobs. And there are some areas that people hesitate to go or don't have a good access to it. So in particular, we are under a pandemic situation, and we are having a higher awareness of the hygiene and sanitization. So I believe that the market is there, and the market of cleaning robots is definitely prominent. So maybe on top of robot, just by not only by cleaning, but disinfecting, it could be a good option for the industry.
Thank you. And actually, I wanted to ask this question. Who are you? Can you introduce yourself? My company is called Songju Comtech, and it has little things to do with robots. Container? No, we are producing computer PCs. But I have personal interest in robotic industry since I have a mic. So workers are very reluctant to see the adoption of this technology because we need to work with machines, but it is very difficult to persuade that it will be good for them as well. So do you have any good know-how of persuasion? So what is a good persuasion strategy? If you just focus on the productivity, replacement is not a good choice because it reduces the job. But if we approach this from the perspective of safety, maybe it would be better for persuasion. So when robots are introduced to each industry, the people would be reluctant to see it coming because they will lose jobs. So what would be the best way for persuasion for them? And yeah, that was the question actually. So let me explain by myself about this because I have that curiosity as well. Because in my presentation, I briefly talked, and that is one of my greatest concerns. So honestly, I cannot say that I solved the problem and this is what you should do. I don't have any clue yet. But maybe I can suggest the directions I chose. For example, these are not the replacements of human workforce. I continuously tell them that you will be supported and assisted. because people working on the ground, the team leaders or group leaders or those people who are very close with always have a talk with me, and I tell them why these robots are needed and what kind of role this robot can play. And I tell like this, let's say that this 80-kilometer tires can be lifted by a human being, but they always tell that they have a wrist pain, and this is painful for them. And the company need to pay for them in the form of the industrial accident compensation. So this is so painful, and there are not many robots that can be as efficient as human beings, and it will not be produced in the near future. But if you can be assisted by robots, and if that improve the product, not only productivity, but also help you to reduce the possibility of getting skeletal muscular diseases. So you may think this problem from that perspective. So if you like it, you can take it. If you don't like it, then you don't need to take it. So I'm trying to ease their concerns, and they are so good at listening to what I say. And some people are very reluctant to listen to what I have to say every time. So this is not a perfect solution, but safety and less industrial accident are the two tactics you can use.
I hope I answer your question. Maybe Mr. Yun can add something. Well, I have a similar opinion. As I mentioned before, the purpose of introducing robots should be CES. I mentioned about CES, and this S stands for safety. Let's say we pay a lot for people. Still, people don't want to do difficult, repeated, and some hard work with the potential errors. So if we try to explain this in the economic context only, you won't have any answer. First, most important part will be still some opponents are the workers who want to make some money, and they are concerned that they may lose a job due to the introduction of the robot. So even for these opponents, it's necessary to have a better understanding of the introduction of the robot. And then second, yes, machines can do some hard work for human, but then you only expend more capacity of the machine, but then there will be more share by the machine, but we still have to coexist in the market. So that's how I suggest you should approach to this problem. Okay, let me just briefly jump into the session. Somebody online asked us a question. You talked about there are some commercial values. There will be a significant cost to introduce the logistics robot. And in his engineering, we have the disinfection robot. Okay, I mentioned about disinfection robot. There are two elements, UVC and the pesticide part, and the UVC is also a good way, but if the human body is directly exposed to it, there might be some damage. For example, in summer, let's say you have canopy type of tarp, then you imagine UV is sometimes harmful, and there are A, B, and C type, and UVA is the weakest, but it's still harmful. So if it's UVC, if bare eyes are exposed for more than 10 seconds, there will be some eye-related diseases caused. So you have to pick some areas where there's no one. But for example, by spraying type of disinfection, we have to be careful you have to be careful of using it, because you don't want to spray directly onto the human body. And I mentioned about the UV ray. There are a large area of the panel, and that's where UV is installed. So physically, there are some areas that human workers cannot reach, and then that's where we will use the UV type. Maybe the side way, maybe we can do some spray type. Well, maybe spray type is much better, but the more we use a spray type, you need a bigger container. So as an alternative, we should use the UV type for those areas that the human workers cannot reach. So the combination of these two will be an ideal. Thank you for the answer. I have a gentleman from Tucson Research Institute. I heard that you have lots of questions, so maybe I'll give you a chance. My name is Kim Dong-wook, the manager from Tucson Research Institute. We are doing a collaboration robot project, and then we are expanding this project in logistics, and we are looking for some new innovative ways. Palletizing, depalletizing solutions are our recent focus. We've seen a lot of factories and went through a series of interviews. But in the past, in logistics, as Mr. Yoon mentioned, surprisingly, there are some decent automation in manufacturing site and logistics site. But then what we want to do now is done by industrial robot and logistics robot to do some loading unloading work. Then is there any demand in logistics? I'm curious because conventionally their automation is pretty decent, and I wonder if it would be still a good idea to introduce more innovative robot to logistics. And I'm curious about your take on. It would be great if I hear from you too. Do you want me to do it? Yes, please. So far, we call it smart factory. It used to be automated factory. In particular, loading unloading was an issue for automation, because for automation you need to do some standardization for your work process. Let's say you are loading some material. The container dimension should be 1.2 by 1.2, and depending on the size, it should be 11 to 12 feet in length. So it would be an ideal if you have a standard size of the container. But of course, if you do manual work, is actually more beneficial, because the human workers will find some gaps. And once I had this case in Ulsan, and people were loading stuff in the container by pallet unit, and we compared difference between automation and the manual work, and there was a 12% difference. That's the volume to be delivered, but the work hour is significantly different. Of course, the pallet work was much faster. So if you look at this, efficiency equaled cost reduction and cost efficiency. So if you think of automation and loading and unloading, of course, there will be a potential future if you think the efficiency will be enhanced by the robot. And in the global setting, standardization is a must. So in that regard, maybe delivering, loading can have benefits from introduction of a logistics robot. Thank you, Mr. Yoon. Let me add a little more. In my area, there are significant needs of such robots. So first you try to find the proper robot, and maybe you are not successful. But of course, vision sense has some limitations. As Mr. Yoon also mentioned, vision camera recognize an object, and then a robot starts operating accordingly. But the difference between the robot and human is that human recognizes the object and the surroundings. So let's say the material is rubber, and then human worker knows already the characteristic of the item, but robot is different. Let's say a robot needs some input information of the dimension in order to proceed with work. Let's say there are some work with difficulties of standardization and palletization, and they have more needs of more developed robots. We just talked about 1.2 by 1.2 pallet work, but you can imagine the general delivery service. That's what's happening, but there are other industries that are not ready with the standardization and palletization. So I feel that there's only a limited areas that are adopting such system and standardization. So I'm glad to hear that opinion from Tucson Research Institute. I would like to add more. So we often work with the automobile component companies as well. Maybe automobile is the industry with almost 90% of automation of their manufacturing. By factory, by components, maybe the processes seem the same or similar at least, but they, as you mentioned, they also have standardization issues, maybe machine loading and the simple stamping, pick and place. I'm not sure if we can develop or invent any robot under multi-purpose and multi-function that can do anything, but otherwise, I'm not sure if robots can efficiently replace human work. I'm not sure. So if I summarize your question, robot process is more like a pick and place. In automobile, then maybe Tucson is wondering which area we should focus on. It should be something that you should pay for our consulting. That's my joke. But let me first start. So yes, it's pick and place based in automobile. But each industry and each company has customized robot, because you have some robot in one process and you see some best practices, and then you want to bring it to another part of the process, then of course it costs a lot by simply introducing the robot from process A to B. It already finished the test and it already finished the verification, but depending on the process and the procedure of the work, customization could be very expensive. And sometimes that customization consulting fee is more than the actual equipment, and that could become constant obstacles, and we have to think of the cost to customize or sometimes invent new robots, and that is why it's getting harder to reach the ROI point. So I wonder if the government can jump into support this area. So some government departments are interested in supporting, so or maybe in collaboration of a similar industry. Maybe it's difficult to apply all companies, but maybe they can come up with some new ideas to standardize a similar process that they have in their factories. So maybe that's how you can find some collaboration and solutions. Customization, to be honest, to me, could be a good experience in knowledge, and it could be a good reference for some companies like your partners or Tusan Institute. Or let's say Hyundai or other big companies with robot business are interested in system integration. If it's possible, maybe do you think it will help the expansion of the robot business? I'm not sure, because customization is mostly done by system integration companies. But I don't know if it will be helpful by big companies. Well, I'm not a professional robotic engineering, but let's say if Hyundai Motors is good at system integration, does it mean that customization in automobile is done perfectly? I don't think so. So let's say from 70s and 80s, our economy was led by large conglomerates, but somehow we are leading this ecosystem not in an ideal way. Maybe if Tucson, your organization, pick and focus on certain projects, you will still have a problem of implement and standardize some processes or find the right locations to some robots. So maybe you can work more on that. And here I think the government can do some role. We talked about autonomous driving robot, and some robots are needed with the higher technologies, but let's say metal-related or automobile-related industries are based on mainly pick and place, and then they often have some accidents. And I think those manual and the physical cause more accidents. So it's also important to improve the level of high quality. But some